Hello and welcome to the next section for Math 120. We're going to be looking at section 6.3, which gets into the rational numbers and decimal representation. So now recall first that the rational numbers was described as the set of all numbers x, such that x is a quotient of integers with denominator not equal to 0. So in general, we kind of reduce that down to describing fractions. So fractions are generally what we're going to be working with. Okay, so the first thing when we're talking about fractions is we like them to be reduced to lowest terms. So we want them as small and as compact as we can possibly get them. We don't like these big giant fractions. So a rational number is in lowest terms when the numerator and the denominator, so the numerator is the top and the denominator is the bottom, remember, they have no common factors. So we can use the following property to reduce fractions. So if we have some sort of fraction, I know this seems a little weird, but let me describe it. So if we can rewrite the top of a fraction as a product of two numbers, so a is one number and k is another number, but then we could also rewrite the bottom as a product where it's b is one number and k is the same number that was in the top, we can cancel those k's out, and that reduces the fraction down to a over b. So that's kind of the idea. We're trying to find some common number that goes into both the top and the bottom that we can cancel out, and that will allow us to reduce it. So looking at 14 and 21. So if we wanted to rewrite that as a product, what would that be where there's a common number in the top and the bottom? Yeah, it's going to have to be 7's that common number. 7 goes into both of those. So we could write this a couple of different ways. If you wanted to say, okay, I know this is equal to 2 times 7, and this is equal to 3 times 7, so the 7's cancel. So this reduces to 2/3. That's one way you could do it. It's a little bit long. Another way that people like to do it is they just like to show it as a division. And they just say, okay, I'm going to divide 7 out of both of those, and it reduces to 2/3. It's the same thing. It's the same thing. So whichever way you like, I personally like this way a little bit better because it's a little bit less work, a little bit less writing. So what about 28 over 36? So what number could we divide out that goes into both of those? Now, anytime that you struggle with these, try something small because you can do it in multiple steps. You don't have to reduce it in one step. You can do it in multiple steps. So looking at 28 and 36, they're both even, which means that 2 has to go into both of those. So if you're stumped as to know what that one number is, start with something small. So let's divide out the 2 first. So if we divide out the 2, looks like we're going to get 14 over, not 36. Let's try maybe 18. So we have 14 over 18. And so my screen went black. Just put that back on. But now, what can we do with 14 over 18? Yeah, we can do 2 again. So that's going to reduce it down to 7 over 9. So you can do these in multiple steps. Now, had you wanted to do it in one step, what would that number have been that you had to divide out? Well, you can kind of cheat and look, we got 2 2's here. 2 2's give you 4. So if I had said I'll divide the top and bottom by 4, that would have brought me right to the answer of 7/9. So there's lots of ways to tackle these. You don't have to do it in one step, is the big thing. All right, so what about 10 over 13? So what number can we divide out of those? You're probably scratching your head saying, I don't really think there is anything. And you'd be right. So there is nothing that goes into both 10 and 13. So in this case, you should write your answer one of two ways. You could just say in lowest terms, and that's abundantly clear to me that it's in lowest terms then, or you can write it like this: 10 over 13 equals 10 over 13. What I wouldn't want to see on your homework would be just you write down 10 over 13 with no explanation next to it. That doesn't tell me that that's your answer. That tells me you wrote down the question. So you got to make sure you put a little bit of notation of some sort to let me know what you're saying the answer actually is. Now, digital homeworks are a little different, obviously, but handwritten homeworks, you should write something like this. All right. Okay. So that's a quick look at reducing to lowest terms. What about checking for equality of rational numbers? How do we know that one fraction is equal to another one? And there's an easy way, and that's the cross product test. So if we have two fractions, a over b and c over d, again, all those are just numbers. If it's a true equality, that the one fraction equals the other one, then the cross products should be equal as well. So a times d and c times b would have to be equal to each other. So it's just a nice, easier way. Instead of trying to divide stuff out, you're just multiplying two things and that's it. So let's see what we get. For this one, if this is supposed to be true, then we know the cross products better be equal. So 45 times 4, is that equal to 60 times 3? Well, 45 times 4, if you don't know, get your handy dandy calculator out, which I happen to have one right here. So 45 times 4 equals, oops, let's try that again. 45 times 4 equals 180. So we got 180 over here, and 60 times 3 is also 180. So cha-ching. So this is true. Now we might not have needed a calculator on that one, but this one is a little bit yuckier, so we'll probably dig it out again. So in this case, again, the cross products. So 54.1 times 60, oops, times 61, is that equal to 123.2 times 26? Well, let's see what we get on this one. 54.1 times 61 equals 3,300.1, and 123.2 times 26, 3,203.2. So they're not equal to each other, so this would have to be false. So pretty quick. A couple multiplications and you can quickly check to see if two fractions are equal to each other. All right, so far so good, hopefully. Now we got to look at operations. Adding, subtracting, multiplying, dividing. But what do we need to add or subtract rational numbers? You remember that stuff? For adding or subtracting rational numbers, adding or subtracting fractions, we gotta have a common denominator. That's the important piece. So now, if you are rusty with this stuff, I'm going to show you two ways to do it. The first way is looking at this formula. So this is a pretty straightforward, well, maybe not straightforward, but it's a pretty uniform formula that you could use. All you're doing is just substituting the numbers in the right spots and simplifying it down. And this will always work. These formulas will always work. But it's a little bit messy looking, right? There's other ways that we can do it based off of a least common denominator. I'm going to show you a couple of tricks for doing it that way. So I'll show you this way, but I'm going to probably lean towards the other way. So, okay, so let's try this formula out with this first one. So I'm going to go right over here. So we got 1 is basically our A, 3 is our B, 7 is our C, and 12 is our D. So we just want to plug all those numbers in the spots on the other side of the formula. So we got 1 times 12 plus 3 times 7 all over 3 times 12. So you just plug all the numbers in, and now we can use the order of operations to simplify it. So we're going to do all the multiplications first, and then we can add. So we get 12 plus 21 all over 36. And then 12 and 21 is 33. Now, we can reduce that. What goes into 33 and 36? There's a lot of 3's in there. So if we divide out that 3, we're going to end up with 11 over 12. So it does work. And like I said, it's a pretty straightforward as far as you've got to plug the numbers in the right spots and break it down. But like I said, the numbers can get pretty large at times. What about another way? If we're looking at the denominators of 3 and 12, there's kind of a relationship going on. We can kind of see that. We know that 3 goes in to 12 evenly. When that happens, all you have to do is change all the denominators to that common one. So since 3 goes into 12, I'm going to change my denominators to 12s. The second one already was, so I don't have to do anything to the top. But because I changed the bottom of this one to a 12, that means I have to change the top to something. And the question is, what do I change it to? Well, it all depends on what you multiply by. If I multiply 3 times 4, that gets me to my 12. So I have to do the same thing to the top. I have to multiply the top by 12, or excuse me, by 4. And that should fix it. So now I got 4 over 12 plus 7 over 12. And if I add the tops, I get 11 over 12. So you get the same thing. So this is a nice way to do these problems when the denominators are cooperative. But when they're not, well, then we got to do something a little different. Let's try this process on this one. Now, we have a problem. 3 and 8, they don't jive. They don't go together very well. So what do? Well, we're going to have to build up from that 8 until we find a number that 3 goes into. So we know 3 doesn't go into 8. So what's the next multiple of 8? It's going to be 16. So now you've got to ask yourself, does 3 go into 16? No, it doesn't go into 16. So what's the next multiple after 16? It's going to be 24. So 24, though, 3 goes into 24. So I should be able to change both of my denominators to 24s. Because 8 goes into 24 and 3 goes into 24. So that's good. That's what I want. Now, I have to change the tops, though. So what would your first top change to? If I went from 3 to 24, I had to multiply by 8. So that means I have to multiply the top by 8 as well. So I'll get a 16 on that one. This one, I only had to multiply by 3, though. So the top of this one changes to 21. So now, because the bottoms are the same, you don't touch them anymore. So we know we're going to get something over 24. 16 minus 21 is going to have to be negative 5 over 24. So it's, can be a little bit tricky, obviously. A lot of people want to do stuff with the bottoms after they get them the same, and you don't. You don't have to. You just carry it down. So you don't add the bottoms over here. You just carry it down. Adding and subtracting always behaves like that. Multiplying and dividing is a little different. We're going to see that in the next video. But for this one, you got to be really careful. Now, let's hit a couple of cases when you have mixed numbers. Now, mixed numbers can be a little bit tricky, and there's many ways to tackle this. I'm going to steer you in one direction just because it will avoid any kind of issues with these numbers, with these mixed numbers. So here's the plan. You're going to want to change all of your mixed numbers to improper fractions. If you do that, then you shouldn't have any issues, and you can apply all these techniques up here that we just used. So now the question is how the heck do I change it into an improper fraction? Well, it's a two-step process. You want to multiply and add. So you're going to take the whole number piece, multiply it by the bottom, and add it to the top. So 3 times 4 is 12, plus the 1 is 13. That is your new numerator. The bottom always stays the same. So I'll just kind of write off to the side here. Oops. 3 times 4 plus 1 all over 4. This one, same idea. Whole number times the bottom plus the top. So 16 plus 7 is 23. So now we can do the same thing we just were doing. So we want to get the same denominator if possible, and this is a nice one. 4 goes into 8 evenly, so we should be able to use 8 for our denominators. So we got an 8 here, got an 8 here. The top of this one doesn't need to change. So what would the top of the first one change to? We got to multiply it by 2. So we should get a 26. So now we can just add those tops together. So we get 26 and 23, which is 49. Now, anytime you have a problem that starts with mixed numbers, you got to end with a mixed number. So we know how to change them, but we got to change it back into a mixed number. And how we do that is dividing. Dividing and subtracting. Just the opposite of what we did here. We multiplied and added. We got to divide and subtract. So let's just take it off to the side here. 8 goes into 49 6 times. And there's 1 left over. Those are the pieces you need for your mixed number. The 6, this is your whole number. And this is your numerator. So we should be able to get 6 and 1/8 from that. And the nice thing about these problems is that if you're not sure if you transformed it correctly, try to transform it back. If we tried to transform it back into an improper fraction, again, we got to multiply. So 6 times 8 is 48, plus the 1 is 49. So it checks. All right, let's do one more and then we'll stop the video here. We're getting a little long. So if we multiply first, 7 times 16 is going to be 112, or excuse me, yes, 112, plus the 3 is 115. So 115 over 16. And again, if you're not sure, dig out your calculator and check. 16 times 7 equals 112, plus the 3 equals 115. So we're good. All right, same thing over here. 4 times 8 is 32. 32 plus 7 is 39. All right, so again, we got a nice relationship here. 8 goes into 16 evenly, so let's use 16 as our denominator. So we had to multiply it by 2 to get it up to 16. So 39 times 2 is 78. And now if we subtract those, what do we get? Looks like we get 37. So 115 minus 78 is 37. And so we got 37 over 16. So now we got to divide, just like we did over here. How many times does 16 go into 37? I think it only goes in twice. And I think there's 5 left over. So 2 and 5/16. All right, so let's stop here, catch your breath, and pick up the rest of it in the next video. See you in a minute.